Sumit Roy here in the basement of the engineering building at the University of Washington. With me is my colleague Professor Kuga, two graduate research assistants, Thomas Chan and Jeffrey Mills. We are here to demonstrate our experimental setup that supports project 2.3. In this project, we are investigating the use of advanced spatio-temporal signal processing techniques for detecting targets of opportunity given the presence of commercially available sources such as broadcast television or other signals of opportunity. I'll hand over to Thomas and Jeff who will provide some demonstration of the setup that we have and tell you a little bit about the results that we have. Thomas, Jeff.
So Jeff and I are going to go over some of the equipment that we have. A function generator, which we can create an arbitrary binary bit sequence in MATLAB and then load it into the function generator, which is shown here. It's 2 microseconds long and a 1 volt peak to peak. And then we also have a 1 gigahertz oscillator, and we have a 10 megahertz output which we use as a sync, and then that syncs back to this function generator, so they're synced with each other. Output of the function generator signal and the output of the 1 gigahertz oscillator are mixed together, and the output of the mixed signal goes into this power amplifier, and so we can get a bigger signal. The output of the amplifier, one of them goes directly into the oscilloscope and is shown as channel 1 as the reference. That's the yellow guy. And the other one goes to our cell phone transmitter right here. So the signal that's coming out of the cell phone antenna is received from these lambda over 2 dipole antennas at 1 gigahertz, and then they're hooked back to the oscilloscope as channels 2, 3, and 4. So for the correlation process, we can correlate the received signals 2, 3, and 4 with the reference signal to figure out the range for the AOA processing. And we can zoom in and run the music algorithm on this data, which should give us the angle of the target. Next, we took all of our equipment outdoors and tested our algorithm using this cylindrical target, which is made out of tinfoil as a reflector.
This is a block diagram of the setup we used outdoors. The transmitter was put behind the column to block the direct path. We then tested the target at 3 positions, measuring distance using the correlation method and angle of arrival using the music AOA algorithm. These are the results from the outdoor experiment. As you can see, for positions 2 and 3 the results are close, and at position 1 there is room for improvement. Using our correlation method, we generated range ellipses for each of the 3 target positions represented by the red dots. As you can see, the measured range matches the actual position quite well. So far, we have shown that our algorithms work pretty well when blocking the direct path using a column. The next step is to get similar results without the need for blocking the direct path. We are currently implementing an adaptive filter to do this. Thank you for watching our video.